So, yeah, write chapter 4 on that first page, and then turn to your actual first page of chapter 4 where we're gonna write a couple of things in there before we go to your whiteboard. Okay, so we are gonna do multiplication of fractions, which is actually a ton easier than adding and subtracting, which is kind of funny. But, so if you'll write multiplying fractions. Okay, multiplying fractions. Okay, so we're starting, here, let me give you this before you sit. I'm starting chapter 4, so this needs to go on chapter 4. And then, once you get to your first page, if you'll put multiplying fractions. Okay. Let me get a little bit, okay. Let's put this as our first example. So we're gonna put 1/5 times, okay, 1/5 times 2/3. Okay, all we do is multiply across the top and multiply across the bottom. So what do we get when we multiply across the top and we multiply across the bottom? Liana?
215.
215, so that's our answer.
Really?
Okay, a lot easier than adding and subtracting. You don't have to get a common denominator and all that. But there's something that can happen in multiplying fractions that we're going to put an example of that second. So let me get Grayson, make sure you write this down. And then actually I'll have room to write it underneath here. I'll just put it underneath here, the next example. Okay, so write 3/10 times 2/5. Okay, now this problem is different than the last one, okay? So you look at numbers that are across from each other, okay? You look at numbers that are across from each other. And you see if they have anything in common that goes into both. So for instance, in this problem, we didn't need to worry about that because 5 and 2 don't have anything in common that goes into both of them. And 3 and 1, I mean 1, but 3 and 1 don't either. So here we're looking at 3 and 5. They don't have anything in common that goes into both of them, but 2 and 10 do have something that goes into both. So what's something that goes into both 2 and into 10, Cannon?
2.
2. So what we're going to say is 2 goes into itself once, so we're going to change that to a 1. And 2 goes into 10 5 times. Okay, this is called canceling. So if you want to write that, you can. Okay, canceling. So canceling is when you look, and sometimes you won't, nothing can cancel like that first example. But if you can cancel, you want to cancel, and then you do the math. So you say 3 times 1 and 5 times 5, and then we get our answer. And so what would we get, once we cancel, what would we get here? Harrison? 3/25. Now, most of the time, not always, but most of the time, if you cancel correctly, you're going to have an answer that doesn't need to be reduced. It's already in simplest form, okay? Most of the time. Not always, but I would say like 95% of the time, if you cancel correctly, you're going to get an answer that does not need to be reduced. Okay? Okay, we're going to come back to your composition book in just a second, but let's go to your whiteboard for a minute and let's try some multiplying fractions. Okay, some multiplying fractions. So again, sometimes you won't be able to cancel, so you're just simply going to multiply. And then other times you will be, and so it helps you cancel it down, you get smaller numbers, and then you don't end up with something that needs to be reduced, which actually saves you a step at the end. Okay, let's look at this problem. Let's do 3/8 times 1/3. Okay? So anytime you see numbers across from each other that are the same, okay, then you just know that 3 goes into itself once. So anytime you see numbers across from each other that are the same, you automatically know that they're both gonna become a 1. Okay, so anytime you have numbers across from each other that are the same, they just become 1, because 3 goes into itself once, 3 goes into itself once. And then we just multiply. So what would we get for our answer for this one? Ryan?
1/8.
1/8. Exactly, 1/8. Okay? So anytime you see numbers across from each other that are the same, just go ahead and make them both 1, because you know that they can be made to both be 1. Okay, so let's try a couple of problems, and then we're going to put one more thing in your composition book. Okay, let's do 5, 6 times 2/9. Okay, so first we need to see if we can cancel anything. So we're going to look at 5 and 9 to see if anything goes into both of those, and we're going to look at 6 and 2. So are we going to be able to cancel anything, Gia?
I was going to say 3 can go in 9.
Yeah, it can, but we're looking at 5 and 9. We're saying, do 5 and 9 have anything that goes into both of them? No. But what about 2 and 6? Do 2 and 6 have anything that goes into both numbers? 2 does. 2 goes into itself how many times, Gia?
3. Wait, no, 1 time.
Once. How many times does it go into 6?
3.
That's our canceling. Now all we do is multiply. So what would we get for this problem, Ryan?
5/27.
5/27. Okay, 5/27. Okay, let's try another one. And so again, your multiplication facts come back again. Like I said, multiplication affects so many different things, like knowing how to cancel is knowing your multiplication facts. Okay, let's do, let's do 6/7 times 7/8. Okay, so first of all, we automatically see that we have 7 and 7 across from each other. So what do we know since we have the same number across from each other here, Dean?
Change them both to 1.
Right, we know they're both going to become 1. Okay, let's look at 6 and 8. Does 6 and 8 have anything that goes into both of those numbers? Do they have anything in common that goes into both of them? Harrison?
They both have 2.
They both, 2 goes into both. And so Harrison, how many times it go into 6?
3.
And how many times it go into 8?
4.
Now all we do is multiply, we have our new canceled numbers.
3/4.
And what would we get, Cannon?
3/4.
We would get 3/4.
Subtract 1.
Okay, so once you cancel everything down, you have small numbers to multiply, and then, like I said, most of the time, you will not need to reduce, it'll be already reduced. Okay, let's try, let's do 8/27 times 9/20. Okay, you're gonna be able to cancel both ways because 9 and 27 have something in common that goes into both, and 8 and 20 have something in common that goes into both. Okay, and you want to get the biggest thing, because 8 and 20 actually have a couple of things in common that go into both, but you want to try to find the biggest thing that goes into both. And so let's just start with one of them. So just pick 9 and 27 or 8 and 20 to start with. And so, Dean, what can we do here?
9 and 27 is the biggest number that can go in there.
Right, so this becomes a, and this becomes a, 9 goes into here, 3. Yeah, so you're saying 9 goes into this once, 9 goes into here 3. Okay, and then what about 8 and 20? What would be the biggest thing you can think of that would go into both 8 and into 20? Ryan?
4.
4. So 4 goes into 8 how many times?
2.
And it goes into 20 how many times?
5.
Okay, and then all we do is cancel what we have left. Okay, so what would we get when we cancel, I mean, we canceled already, but what do we get when we multiply all of that? Grayson? 2/15. Okay, 2/15. Okay, let's go flip back to your composition book real quick, because there's two other things that you can see when you're multiplying with fractions. So let's look at two other things that you might see. Okay, so one thing you might see is this. You might see a whole number multiplied by a fraction, okay? A whole number multiplied by a fraction, and it's actually really easy. So let's put this example in your composition book. So we're gonna do 30 times 1/10. Okay, and you actually saw this on the math net the other day, because I saw several people were like, wait, how did they do that? So all you do is you put a 1 underneath the whole number. Because 30 over 1 is really just 30. So you just put a 1 underneath the whole number, and then you cancel just like we did a minute ago. And so you can cancel the 30 and the 10 because 10 goes into both numbers. And so what would happen when we cancel the 30 and the 10? Grayson?
The 10 is 1 and the 30 is 3.
Exactly. Okay, so then when you multiply, you're going to get 3 over 1, which is really just a 3. Okay, so if you have a whole number, just stick a 1 underneath it and work it like normal. Okay, and we'll do a couple of those. And then there's one other thing we need to put in your composition book, and then we'll be done. This word in math, okay, the word of, and I actually added this to the wall up there. Of means multiplication. So if you see the word of in math, in a word problem, or whenever you see the word of, it means to multiply. Okay, so just write that in there, that of means multiplication. Okay, of means multiplication. So if you ever see the word of, you just take it out and put a multiplication sign in its place. Okay, and so let's put an example of one of those problems, and then we'll go to your whiteboard and do some of each one of those. Okay, so let's say we're going to do 5/8 of, okay, 5/8 of 4/9. Okay, 5/8 of 4/9. Okay, so that just means multiply. Of is just another way of multiplying. So you could actually just do this if you wanted to. If you're working this problem, just do this. That's really a multiplication. And then we work it like normal. Okay, of just means multiply in math. So we can cancel the 4 and the 8 on this problem. And so what happens to the 4 and the 8? Harrison?
The 8 turns into a 2, and the 4 turns into a 1.
Right, 4 goes into itself once, and 4 goes into 8 twice. Now all we do is multiply. And so what do we get for this one? Maya? 5/18. 5/18. Okay, so that we have in your composition book now everything you need to know about multiplying with fractions. So let's just go to our whiteboard and do a couple of the different kinds. So you might see of, you might see a whole number, or you might see 2 fractions. Okay, let's do 4/5 of, okay, and actually, as you're writing it on your whiteboard, you can just not write of and put times, because you know that of is times. So 4/5 of 4/7. Okay, and so you could have just written this, as I said of, you could just put times. You can't cancel anything here, because nothing goes into 5 and 4, nothing goes into 4 and 7, so you just multiply. Okay, so if you look at it and nothing can be canceled, you're just going to multiply. And so let's see what we get. Cannon?
16/35.
16/35, and you can't reduce it. Okay, and most of the time, if you can't cancel, you're not going to be able to reduce it. Okay, so you just get 16/35. Okay, let's try another one. What about 15? Okay, so we've got a whole number, so you could actually go ahead and write 15 over 1. So 15 times 2/3. Okay, 15 times 2/3. And remember, if it's a whole number, you can just stick a 1 underneath it. Okay, and 15 and 3 are going to cancel. Okay, 15 and 3 are going to cancel. And so what happens with 15 and 3? What's the biggest number that would go into 15 and 3. Ryan?
3.
3. So 3 goes into itself,
1.
and it goes into 15.
3 and 5 times.
Okay, and then we just multiply. Okay, so what would we get, Grayson?
10.
10. Yeah, 10 over 1 is just 10.
And I'm.
Yes.
So does it matter which way you cross them out?
It's a diagonal. Yeah, you're looking at the numbers that are diagonal from each other. So if you're canceling, you're looking at these 2 numbers and you're looking at these 2 numbers. So it's always, you're looking at the numbers across from each other. Okay, let's try another one with a whole number. Let's do this one, because something's gonna happen on here that's you're gonna have to use something that we've learned recently. All right, so let's do 45 times 5 over 27. Okay, 45 times 5 over 27. So we're gonna put a 1 underneath the 45. Okay, and 45 and 27 have something in common that goes into both. Okay, 45 and 27 has something in common that we can cancel. So Harrison, what would that be? 9 goes into both. So what happens here?
The 27 goes into 3.
Right, 9 goes into this 3 times and 9 goes into here.
5.
Okay. Now, when we multiply, look what happens. We get 25 over 3. Okay, we have an improper fraction. And what do we do every time we have an improper fraction? What do we want to do to it? Because we can't leave our answer like that, Dean.
Make it a big.
We need to make it a mixed number. Okay, so we need to make that a mixed number. So what would we get if we make 25 thirds a mixed number? Cannon.
8 and 1/3.
8 and 1/3. 8 and 1/3. Okay, let's look at one more like that, where we're gonna get an improper fraction answer. Let's see. Let's do 24 times 5/16. 24 times 5/16. So again, we know we're putting a 1 under the 24. And 24 and 16 have several things that go into both. But what would be the biggest number that would go into 16 and into 24? Harrison?
8.
8. Okay, how many times is 8 going to 16, Harrison?
5.
And how many times does it go into 24?
3.
Okay, so we're going to get 15 over 2. Now, let me tell you something about 2. If there's an odd number on the top and there's a 2 on the bottom, your answer is always something and a half. Okay, your answer is always something and a half if there's an odd number on top. If there's an even number on top, it goes in evenly. But 15 divided by 2 is something and a half. So what would we get for 15 divided by 2, Ryan?
7.5.
7 and a half. Okay, so again, if you have 13 over 2 on the top, you're going to get 6 and a half. Okay, it's always going to be something and a half. There's an odd number on top and a 2 on the bottom. Okay, if you will